Hey, good day everyone. Welcome to Marina's Powerhouse Team Review and Training Center. This is part 2 of Millman's Theorem. So this is actually a direct current circuit part 16. Okay, let's go on to our next problem. By the way, before we solve this next problem, so I'm inviting everyone to please subscribe to my YouTube channel. So that is the Reggie Marina YouTube channel. So you will see there our logo and the name of our company, the Marina's Powerhouse Team Review and Training Center. So we are an engineering review center, actually. So we're offering online review. So wherever you are, you may have your online review program, right at the comfort of your home. Okay. Okay, so we are solving problems from this book, some of the problems from this book, and we are applying Millman's theorem to simplify the solution. So let's see. Okay, let's go over with problem number 4 of the Millman's theorem. The LRT trolley system, LRT by the way is the light railway transit. It is a railway system here in the Philippines. The LRT trolley system, 10 miles long, is fed by two substations that generates 600 volts and 560 volts respectively. So let us draw our circuit. Okay, so drawing natin. We have a 2 DC substation. A railway is a DC system. Okay. Take note that there is 600 volts source here. Then we have 560 volt source. The resistance of the trolley wire and rail return is 0.3 ohms per mile. So let's say this is our train. Okay, this is our train. Then there is a rail here and this is our trolley wire. Okay, wherein it gets a connection here. Okay. This will be our catenary. So this is where the train gets its source. Okay. So we have these two stations. So the resistance of the trolley wire and rail return is 0.3 ohms per mile. Actually, that is the loop resistance. So let's see. We have here R1. We have here R sub 2. Okay. For our R sub 1, so we have 0.3 ohms per mile, 0.3 ohms per mile. Okay. And for our R sub 2, still 0.3 ohms per mile. Okay. So they are both 0.3 ohms per mile. Okay. If the car is located 4 miles from the 600 volts station, so meaning this is 4 miles from the 600 volts going to the car. So let's say this is the car. Okay. The two stations is actually 10 miles. They are 10 miles apart. So therefore, this is 6 miles. Okay. Then let us substitute here. So this is 0.3 multiplied by 4 miles. So that will be equal to 1.2. Okay. 1.2 ohms. What about here? This will be 6 miles. Okay. So that will be 1.8 ohms. Okay. The mile will cancel out. Okay. Cancel. There you are. If the car is located 4 miles from the 600 volts station, it draws 200 ampere from the line. So, Meaning, there is a 200 ampere here. This will be our load current here. 200 ampere. That is 200 ampere. Okay? So, from the line, how much is the current supplied by each station? So, let's say we have here current I sub 1. Then we have here current I sub 2. Okay? So, take a look here. I'll be using the Millman's theorem to solve the load voltage here. Let's say we have a voltmeter here to solve the voltage at the car. See here? See? Take a look here that 1, 2, 3 branches. They are purely in parallel. They are connected in parallel. Ha? Purong parallel sila, mga kawerpa. So, kunin natin, let us get our V sub L. Here. Load voltage. That will be equal to what now? For the first branch, we have 600 over, that is R1 in series with the 600. R1 is 1.2. Okay. Then plus. I will consider this first. So we have 5. Then over R2. R2 is 1.8. Okay. What about in here? Take a look here, guys. What about if we don't have a voltage, we don't have a resistance, we only have a current? We only have a current. Take a look here. From our formula, V is equal to the short circuit current all over the summation of conductances. Okay. Our current here. Remember that the numerator is actually the ratio of the voltage to the resistance. So therefore, it is a current. That is still a current. This is a current. This is also a current. Now, so we have 200 ampere going downward. There is a sign convention. Take note. If the current is upward, it is a positive current. If the current is downward, it is a negative current. It's just like a force in physics or engineering mechanics. If the force is upward, that is a positive force. If that is downward, that is a negative force. Okay? So, we have here our IL going downward. So, therefore, it is a negative current, negative 200. Then, what about the conductances? Just take a look here. So, 1 over 1.2 plus 1 over 1.8. No more. Okay, there will be no more here for 200. Just put here minus 200. So, our BL now will be equal to what? Okay. So, our BL will be 600 over 1.2. Okay, then we have plus 560 over 1.8. Then that is minus 200. Okay, then we have here 1 over 1.2 plus 1 over 1.8. Equals. The answer is 440 volts. 440 volts. So that's the answer for the voltage. What about now in getting the current? Okay, in getting the current by the PLM, powerhouse let it flow method. How is this? So, let's say for I1, let us consider this loop. Guys, let it flow here. Let it flow here. Okay. Take a look. This is positive. This is negative of the voltmeter. So our I sub 1 will be equal to what? Our I sub 1 lives on the positive terminal of 600 volts. So therefore, it is positive 600. It lives on the negative terminal of B sub L. That's why minus B sub L. What about now the resistance path? We have here R sub 1. R sub 1 which is 1.2. So that is the value for I1. What about now for I2? Okay. For I2, what do we have here? Take a look here, guys. For I sub 2, let us consider always the voltmeter. Let it flow. I sub 2 is this. Let it flow here. Only one complete loop. You're assuming that there is no load here. There's only one complete loop here. Now, we have our I sub 2. It lives on the positive terminal of 560 volts. This is the positive terminal. So, 560 minus. Why is it minus? Because this I sub 2 lives on the negative terminal of this. Divided by the resistance path, we have R sub 2 that is 1.8. So that is equal to what? Now, okay guys? So, let us complete now the solution. So let us find 600 minus BL, which is 440, equals divided by 1.2 equals. So the answer is 133. 133.30. What about here for 560? So we have here 560. Then we have minus equals, then divided by 1.8. So that will be equal to 66.6 amperes. Okay? That is the answer for I1 and for I2. How to check our answer? If that is right or wrong. How to check? Just check. Okay? Is that the right way? Of course. So take a look here. So we have here at node A by, let's say to check by Kirchhoff's current law at node A. Take a look here, guys. Kirchhoff's current law at node A, of course, the current entering is I sub 1 and I sub 2. Here. This is I sub 1, this is I sub 2. That's equal to IL. No? I1 plus I2 is equal to 200. Are they equal? Let's see. Take a look here. I'll not write it anymore. 133.33 plus 66.67. So you just have to add. Okay, the answer is yes, that's correct. No? The answer is 200 if you are going to add these two. We already showed the solution here of this problem before using the nodal method, using the superposition. No? So, we advise you to also watch our previous videos. Okay? So, that's it. The answer would be letter. Okay, that will be letter C. Okay, let's go now to the problem number 5. There you are. So we have problem number 5. I have to draw the circuit here. Take a look this figure. Although there are just some curve here, no, it's just a purely parallel circuit also, no. So ganun din yon, purely parallel circuit din yon, mga kawerpa. So I will just draw this circuit, no. This circuit, no. Okay, masanay tayo dito sa ganitong klaseng circuito. So we have 2 ohms. We have an independent current source. Resistor here. Okay. This is a 2. Then we have the second branch is 30 ampere going upward. Okay. There. It is 30 amperes. The next branch The third branch, we have the 6 ohm resistor. 6 ohm resistor. Wherein we saw here that we have a voltmeter. This is actually a voltmeter. V. So, we have here a positive, then we have a negative. Now, you are thinking that there is a voltmeter being tapped, no? In parallel with the 6 ohm resistor here, wherein this is the positive terminal of the voltmeter and this is the negative terminal of the voltmeter. Okay? And the next branch, we have the 4 ohm resistor. Take a look here. We have 4 ohms. Okay? 4 ohms. Then we have here 8 ampere that is going downward. There you are. So we have here 8 ampere downward. So the question here, find V. What will be our voltage V here? Okay? This is very easy. This is very easy. So just make use of Millman's theorem. Okay? Again, by Millman's theorem. Take a look here, guys. By Millman's theorem, so we have here, what now? V. Okay. So, for the first branch, there is no voltage here, so I'll just make it as 0 over 2. For the second branch, we have a 30 ohm. After 30 ampere, sorry, 30 ampere current. That's going upward. So if that is upward, that is a positive current. Positive 30 amperes. Okay? There. What about in the 6 ohm? Okay, so there is no series voltage. 0 over 6. 0 over 6. Again, this is 0 over 4. There are so many zeros here. Okay. The current 8 ampere is going downward. Therefore, it is minus 8. Because it is going downward. Minus. Okay. What about the summation of conductances? We have 2 here. So, that is 1 over 2. Okay. So, this is just a current. Do not consider this. We have here the 6 ohms. 1 over 6. Then we have the 4 ohms. 1 over 4. So, this is 1 over 2 plus 1 over 6 plus 1 over 4. Okay. So, simply, this is just 0. This is also 0. This is also 0. Okay, guys? So, what? Let's go straight with our calculator. So, ngayon natin, mga kawerpa. Solve natin. 30 minus 8, that is 22. Okay? Then, divided by 1/2. Okay? Then, plus 1 over 6. Okay? Then, plus 1/4. There you are. Plus 1/4. Okay. So, our answer would be 24 volts. That's the answer. Okay? That's very easy. Oh, what letter is that, partner? Anong letter yan? Letter B. Okay, letter B. Okay, let's solve another problem. Okay. This is actually a problem from DC machineries. Okay, we can make use also of the Millman's theorem here. This is our last problem for this topic. Okay, wherein we apply our 2 generators in parallel to supply a common node. No? A load, I mean. We have a load. So let us draw our problem number 6. 2 shunt generators are operating in parallel are giving a total output of 320 kilowatts. Generator A and B, so with a given armature and induced EMF. No? So find the bus bar voltage. No? This is assuming that neglecting the shunt field current. No? We'll go there once we go to DC machineries. Okay. So, but first, this is just a basic principle from DC circuits. I will draw first our circuit. We have two DC generators. It's just like having okay. Then okay. So we have a given volt induced EMF 450. This is 450 volts. Then we have another one, 460 volts. Okay. What about their resistances? For 450, it is 0.02 ohm. 0.02 ohms. Okay. For 460, we have 0.025 ohms. So take note that it supplies this given load. Find the bus bar voltage. Okay, what is a bus bar voltage? This is the bus bar voltage. A bus bar, it is a conductor where we connect the two generators to the load. Okay, so if we have a voltmeter here, this is the bus bar voltage. One common voltage, and that will be our Millman's voltage for this circuit. No? Can we show the solution from the book? Partner? Next slide. Meron ba tayo niyan? Yung solution natin. Okay. There. You see, it's quite a long solution. So, how many steps before we go to the final answer? From IA1 plus IA2 is equal to IL. That's one line, the first line. Let us count. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 lines, no? What if we replace that by one line? Isn't it great, right? Okay. So, let's go back to our question, partner. Our load is around, how much is that? 320 kilowatts. Huh? Our PL is 20 kilowatts. Okay? 320 kilowatts. Take note that there is a current flowing to the load. And of course, PL is equal to VL IL. Then our IL will be equal to PL over what? VL. Of course, our IL will be 320 kilowatt or 320,000 watts divided by VL. So, using the Millman's theorem, again, our load voltage B is equal to the summation of the short circuit current over summation of conductances. So, this is our basic formula for Millman's. Now, let us have this. Our BL will be equal to what? This is the one line solution. Take a look. Here. We have here 450 over 0.02. About this, 460 over 0.025. By the way, it so happened that for the battery, this becomes negative and positive, meaning polarity. So, you have to make this as negative, no? Ganon, ha? Diba, ito yung naging negative mo, positive. Ito kasi positive, negative. If we make this as negative and positive, you should replace this by negative. Okay? Did you get that? Okay? So, There is a current here going downward. Therefore, minus 320 over BL. Okay, you see? Then what about now? For the denominator, that will be 1 over 0. 0.7. Okay, there you are. So this is just a current. Okay? There will be one unknowns. There will be one unknowns only here. Okay? So isa na lang ang unknowns natin dito mga kawerpa. No? Only one unknowns. Okay. So take a look here. We'll be solving this in a conventional way, no? Although there are a lot of things to solve this, no? So I want to be detailed on this solution. Take a look here. So let us calculate this first. This value. Natin. Yan. We have 450 over 0.02. Okay, then we have plus 4 over 0.025 equals. Okay, so this is actually, so what about how we have 1 over 0.02, okay, then plus 1 over 0.025, 0.025. So the answer is 90. So that is 90. Okay. So let us just cross multiply. V sub L will be equal to 40,900. Okay. Then this is minus, that will be minus 20,000 BL. Okay, as you see this one here, so that will become 90 BL, minus will become plus 320,000 over BL. Okay, so I transpose this. Negative will become positive. This positive, I will transpose this all. 1,900. That is equal to 0. Now, as you see here, I will by BL. So that will become 90 BL times BL, that is BL squared. Okay. What about here? So we have here plus this. That will just be 320,000. Okay. So this will be negative 40,900. Let us have this the quadratic here. So the standard form 90 BL. About this one minus 900 B sub 320,000. Okay, in our mode By the way, to our non-Filipino friends or students who are watching right now, we are using this is the model that we are using here in the Philippines, being approved by the professional. We are using the Casio X991. This was disapproved by the professional, but they have the same function as the FX570 ES Plus. In fact, they only have one manual. The only difference is the solar power here. So, I'm just wondering if this was disapproved by the board, where it's almost the same, no? For the function, they have the same function. Or we can make you 570 ES Plus, the second edition, the black one. Okay? So, they all have the same function keys. Okay? So, let us apply mode 5.3 in this problem. Mode 5.3, so we have 90 equals. Then we have negative 40,900 equals. Then we have 320,000 equals. Then you press now equals. So the answer here for x sub 1, which happens to be the first value, 446.48 volts. We have another value here for the next, let's say VL1, VL 7.96 volts. Actually, if you are going to use our calculator directly using the shift solve function, this will be the answer. If we stop here, then use equals, once we input the equation, 7.96. This will not, the calculator will not show to you this 446.48. Wherein, if we are going to expand this, no, this is actually quadratic equation. So, x is squared. So, it must give two roots. So, dapat dalawa yung roots, x1, x2, x3. So, ganon. If it's squared, that is x1. Remember that. Okay? So, as we see here, we have 446.48. So, the answer would be, partner, that is nearest to letter. Okay, that's correct. 446.5, 446.48. Huh? Next, do we have any? I think that's the last. So, as we see here, okay, there are so many steps. So, we shorten the number of steps. Okay, so with this, so I should say, salamat po sa end of our Millman's theorem. So I will see you on the next video. Thank you.